Hello, Calc AB friends. We're here today to talk about net change. So this is like absolutely one of the key things. And if you had to understand like kind of one concept or one equation for the AP test, this would be the one. Okay, so this is just a way to think about definite integrals. And what I want to remind you of is the fundamental theorem basically says this. If you were to integrate some function, some derivative from a to b, that will give you f of b minus f of a. But when you're thinking about what this represents, what this is saying is that the integral of the rate is equal to some f of b, which is some amount. So if f is some amount of something, and then f prime is the rate of change of that amount, then f of b is like your final amount, and f of a is like your initial amount. So it's saying that if you integrate a rate from some time a to some time b, you get the final amount minus the initial amount, which we could also think about it as the net change in f, the net change in f from a to b. And I think kind of really thinking about that if you integrate a rate, it tells you how much f changes from time A to time B. So we're going to work through a bunch of examples and problems where this is useful, but it turns out to show up all the time in the AP test. So let's go with a realistic problem here. My IQ is increasing at a rate of tq plus 1 points per minute. How much did my IQ change from 0 to 2? Okay, so if I want to find like my change in IQ, what that's saying is I just need to integrate the rate of change of my IQ from 0 to 2. I just need to integrate 0 to 2 of tq plus 1. Now, this is a definite integral you already know how to do. All of these you know how to do today. The only difference is just the setup and thinking about it from a real-life perspective here. Okay, so from 0 to 2, I got t to the 4 over 4 plus t. When I plug in 2 to the 4 is 16, so I get 4 plus 2. When I plug in 0, of course, I get 0 and 0, so that turns out to be 6. So that's saying my IQ changed by 6 points, positive 6 points, from time 0 to time 2. So over the 2 minutes it took me to do this problem, I got 6 IQ points better, which sounds about right. Okay, so that's the idea, that again, you integrate a rate, you get some kind of change, how much it changes. But you can also do it in problems like this, where they give you an f prime, you're given a point, and they ask you to find another point. This is just the fundamental type of problem where you'll see the fundamental theorem of calculus. They give you f prime, they give you a point. So the idea is, let's set this up. And for your a and your b, you're going to use the 2 points that are given. Just pick the smaller one to be a, although it really doesn't matter, and the bigger one to be b. So that's saying, if you were to integrate 0 to 2 of f prime of x, that's going to give you f of 2 minus f of 0. Okay, so what is that integral? Well, that's saying integral 0 to 2 of 3x squared dx equals, and the problem told me that f of 2 is equal to 7. Okay, so then all we have to do is do that integral. So that's just x cubed going from 0 to 2. So that's 8 minus 0 equals 7 minus f of 0. Okay, so subtract the 7. So 1 equals negative f of 0. So f of 0 equals negative 1. So if you ever have a problem like this where they give you a point, they give you a rate, and ask you to find another point, you're going to apply the FTC and use this setup right here. Okay, so let's look at another one. If I have 2 inches of snow in my driveway times 0, snow accumulates in my driveway at a rate. So there's the word rate. So if the rate is 3 rad t, you want to interpret that as saying, okay, my f prime is 3 rad t. When they tell me I have 2 inches of snow in my driveway, so that's saying that f of 0 is equal to 2. You know, when my time 0, I have 2 inches of snow. And the question asks how much snow is in my driveway at time 4, so what does f of 4 equal? All right, and the way you want to address this problem, again, is saying, okay, you know, here's my a, here's my b. I have this rate, this is my f prime. So if I integrate from 0 to 4 of that f prime, I'm going to get f of 4 minus f of 0. Okay, so what is the integral 0 to 4? So that's integral 0 to 4 of 3t to the 1/2. And don't forget the other side. Don't just get rid of this, right? The f of 4 is what we're trying to find. The f of 0 is equal to 2. Keep writing that at every point along the way. So when I do that integral, okay, so that's 3. That'll be t to the 3/2. I will put a 2/3 in front, so those will cancel. Going from 0 to 4 equals f of 4 minus 2. Okay, so again, let's evaluate the integral. So I'll leave the 2 in front. So we have 4 to the 3/2, 0 to any power 0, equals f of 4 minus 2. Okay, so what is 4 to the 3/2? How do I think about that? Well, that's the square root of 4 to the 3rd power. So 2 cubes, that's 8. So that's saying 2 times 8 equals f of 4 minus 2, and then I'll add the 2 to the other side, and I will get f of 4 equals 18. Okay, so that makes sense. So again, the key on this problem is doing this setup. There's nothing new in terms of actually doing the integral. We just need to set this up properly. Okay, so let's get to some other problems. Here's one where you have a table of data. But you're going to use the same setup, right? All of these problems you use the fundamental theorem. So in this case, they tell you g of 0 is equal to 2, okay? But instead of giving you an equation for g prime, they give you a table of g prime. And we're asking you to estimate g of 8, or gate, if you will. Now, I think that one's actually not too bad, right? We have a point here. We're trying to find the other point, g of 8. So let's set up the FTC. So that's my A and my B. So that's saying that g of 8 minus g of 0 is the integral 0 to 8 of g prime of x. Okay, now g of 8 we're trying to find. So g of 8 minus 2 equals. Now the key here is I don't have this equation. I don't know what the equation is here, right? But what I'm going to do is I'm going to estimate this integral using a Riemann sum. So I'm going to estimate, using a Riemann sum. Okay, so basically the Riemann sum replaces an integral. We have g prime. So when I'm trying to go ahead and actually figure this out, what we have here is we're going to estimate this integral by using a Riemann sum with the intervals between points like usual. So the problem tells me it's a left Riemann sum. So my intervals are 0 to 2, 2 to 6, and 6 to 8. And like usual, it's always a good idea to kind of circle the left endpoints just to remind you. So remember, a Riemann sum estimates an integral. So we're estimating this right side of the equation. We're leaving the left side alone, but we're estimating the right side using a Riemann sum. So base times height. So that's 2 times f of 0. Or sorry, it should be g prime of 0. And then that's 4 times g prime of 2 at the left endpoint. So 4 times 5.3. And then 6 to 8, we have 2 times g prime of 6. So that's 2 times 7.2. Okay, so that's telling you that g of 8 minus 2 equals 8 plus, whatever. This is 24.3, okay, that's 21.2, and then plus 14.4. And then we'll just add the 2 to the other side. So g of 8 is equal to 8 plus 21.2 plus 14.4 plus 2. And just leave it like that. That's totally fine. Okay, so that's an acceptable final answer here. You did the Riemann sum. You remembered your initial condition right there. That's the point that's given to you, that 0, 2 right there. But again, the setup is the same, right? Setting up the fundamental theorem right here, we've done again. Okay, let's get to part B of this problem that I kind of squeezed in here. B says, find the integral 0 to 8 of g double prime of x. Now you might think, how can I integrate g double prime if I don't know anything about g double prime? But trust the fundamental theorem, right? Because if you integrate g double prime, that'll give you g prime of x, going from 0 to 8. So it'll just give you g prime of 8 minus g prime of 0, right? If you integrate g double prime, you get g prime. So that's just 5.5 minus 4. I just got those values right here from the table, which is 1.5. Cool problem. Okay, so those are just some of the ways that you can use a table to kind of solve some problems using the fundamental theorem. One more thing I wanted to do. What if you had this? What if you had an f prime graph? You guys remember this chapter, very exciting. You might remember this from your test. I think we used this picture. Okay, so part A of this says, on what intervals is f increasing? That's review. So just to remind you, f increases when f prime is a positive number. That just means f prime is a positive number when we're above the graph. So that happens here on the interval from -3 to -2. Okay, D is the new part. And I didn't give this to you on your test, obviously, because we didn't know how. But what you're going to do is you're going to use this point. We're going to use 0, 3, 0, 3 to find f of -3 and f of 4 using the FTC. So I have that initial condition, I have the f prime. So what I'm going to say is, okay, if I want to find -3 to 0, so if I integrate -3 to 0 of f prime, that's going to give me f of 0 minus f of -3. And what I just need to do here is I just need to interpret this as an area. So I need to think of this as an area. So again, I don't have an equation for f prime, but a definite integral is just an area. So this is another situation where we're going to use that fundamental theorem to find f. That's really what it's good for on these types of problems. So if you have like a point and you have an f prime and you need to find another point, set up the FTC just like I've done right here. Okay, so what is that area from -3 to 0? So this triangle down here is a half times 2 times 2, so that's 2. This triangle up here is a half times 1 times 1, so that's a half. Okay, so that area is 1/2 above minus 2 below, and that equals, okay, and f of 0, they told me was 3 minus f of -3. That's the key here. Just be careful with your signs. So -3/2 equals 3 minus f of -3. Add that to the other side. So f of -3 equals 3 plus 3/2. Okay, now can I use the same strategy to find f of 4? Yeah. And now when you're doing your bounds, just make sure you go small to big. So have the small bound on bottom and the big bound on top. So if I integrate 0 to 4 of f prime, that's going to give me f of 4 minus f of 0. Okay, so what is that? What is integral 0 to 4 as an area? Okay, so if I need to find like that little area in there above the half circle, interesting. Well, what I'm going to do that is I'm going to kind of, let's pick a more exciting color, orange. I'm going to find the area of the rectangle, and then I'll subtract the area of the half circle. So that rectangle is 2 by 4, so that rectangle is 8. The half circle, you can see the circle has a radius of 2. So it's half of a circle, so half of pi times 2 squared, or 2 pi. Okay, so when I need to find that area in there is 8 minus 2 pi. So that's saying, and it's negative because it's under the x-axis. So that's saying negative 8 minus 2 pi is equal to f of 4, what I'm trying to find. And again, that problem told me that f of 0 was 3. Okay, so let's see, -8 plus 2 pi equals f of 4 minus 3. So we'll add the 3, so -5 plus 2 pi equals f of 4. Okay, so that's the fundamental theorem of calculus and applying to these problems. This is just a smattering, and we're going to see this come up time and time again throughout the year. But just make sure that you have this setup right here. This integral f prime from a to b is f of b minus f of a. And think about if you have part of that, like if you have the f prime and you have a point, you can use this to find the other. Okay, thanks for watching. Bring me questions, class. I'll see you guys soon.